A vast, complex map containing billions of points. Each point is a star. Each star follows its own path, some fast, some slow, some straight, some curved. But if you look closely, they all have one thing in common. They're all orbiting something. Just like water being drawn toward a sink drain, just like the clouds surrounding the eye of a storm, all 200 billion stars in the Milky Way are orbiting a single point right at the very center of our galaxy. That point is invisible. It doesn't emit light, it isn't bright. If you looked at it with the naked eye, it would seem as if there were nothing there. But there is something there. Something very large, very dense, and very dark. Its mass is equal to 4 million suns. Its name? Sagittarius A star. And right now, you're only 26,000 light years away from it.
What comes to mind when you hear the term black hole? Perhaps an object that sucks everything in, like a vacuum cleaner? Perhaps a giant wound torn open in space? Perhaps a dark portal, familiar from science fiction movies, that swallows everything that enters it? All of these are partly true, but partly false. A black hole isn't actually an object. It's a region. It's a region where space-time is so intensely warped that nothing, not even light, can escape once it enters. This boundary is called the event horizon. Once you cross the event horizon, the laws of physics no longer work the way we know them. So how do black holes form? Massive stars explode at the end of their lives. This is called a supernova. If the star is massive enough, the core left behind after this explosion becomes so heavy that it succumbs to its own gravity and collapses. A point of infinite density and infinite smallness forms. This is called a singularity. And around this singularity, the event horizon takes shape. But Sagittarius A star isn't just any small black hole. It is a supermassive black hole. In other words, it's a colossal monster sitting right at the center of galaxies, containing millions or even billions of solar masses. And nearly every large galaxy has something like this at its center. So how did we find the one in the Milky Way?
In the early 1970s, astronomers were trying to look deeper into the center of the Milky Way. The problem was this: the center of our galaxy is shrouded in dust and gas. If you look with visible light, you can't see what's there. It's just like trying to look through thick smoke. But radio waves could pass through that dust. In 1974, astronomers detected a strong, compact radio signal coming from the center of our galaxy. This signal was coming from a very small region, and it was very powerful. They named it Sagittarius A star. The asterisk in radio astronomy symbolizes a powerful source. But this was just a signal. Proving that there really was a black hole there was another matter entirely. That's when the stars came into play. If there really is a very massive object at the center of the galaxy, the stars around it will move in a certain way, just as we can calculate the sun's mass from the motion of the planets around it. Astronomers observed the stars in the immediate vicinity of Sagittarius A star for decades. As the years went by, something began to become clear. These stars were orbiting an extremely small point at incredible speeds. A star known as S2 was orbiting this point at a speed of 25 million kilometers per hour, about 2% of the speed of light.
There was only one thing that could generate such a powerful gravitational force in such a small area: a supermassive black hole. Mass 4 million suns. The two scientists behind this discovery, Reinhard Genzel and Andrea Ghez, were awarded the 2020 Nobel Prize in Physics. We cannot see black holes because they do not emit light, but we can see their surroundings. Around a black hole, in a region close to the event horizon, gas and dust swirl. This swirling matter heats up, glows, and emits light. This is called an accretion disk, and right in the center of this disk, the black hole's shadow, a dark silhouette, is visible. In 2019, the Event Horizon Telescope project captured the first ever image of a black hole. But it wasn't Sagittarius A star. It was a much larger black hole at the center of the M87 galaxy. Sagittarius A star's turn came in 2022. By linking 8 radio telescopes from around the world, they created a virtual telescope the size of Earth. And with that telescope, they looked at the center of our galaxy. What they saw, in shades of orange and red with a dark ring at its center, was the first ever photograph of Sagittarius A star. But taking this photo was no easy feat. That's because Sagittarius A star is very active. The matter around it changes very rapidly. While the black hole in M87 remained relatively stable over hours, Sagittarius A star changed within minutes. They took thousands of individual frames, and by combining them all, they created that image. We saw the heart of our galaxy for the first time.
26,000 light-years. What does this number mean? Light travels 300,000 kilometers per second. In 1 year, it covers approximately 9.5 trillion kilometers. 26,000 light-years is the distance light would travel in 26,000 years. When you look at Sagittarius A star right now, you're actually looking back 26,000 years. The light you see at that moment set out from there when humanity was still living in caves. So, does this pose a threat to us? The short answer, no. 26,000 light-years is a vast distance, even on a cosmic scale. Sagittarius A star's gravity doesn't directly affect us at that distance. The sun's gravity is far more dominant. But that doesn't mean it's completely irrelevant. Our entire galaxy orbits Sagittarius A star, including the sun. The sun completes one orbit around this massive black hole approximately every 225 to 250 million years. This is called a galactic year. So, since the Earth's formation, the sun has completed only about 20 orbits around Sagittarius A star. Compared to the age of the universe, even a galactic year is very short.
Sagittarius A star is currently considered quiet. In other words, it isn't actively devouring large amounts of matter, but this hasn't always been the case, and it won't always be this way. Billions of years ago, Sagittarius A star was much more active. Back then, the center of our galaxy was a region so bright and energetic that we can't even imagine it today. This is called an active galactic nucleus, and it still becomes active from time to time. In 2013, a gas cloud called G2 approached Sagittarius A. Astronomers were excited. Perhaps the black hole would swallow the cloud, leading to a massive burst of energy. They waited. The black hole swallowed the cloud, but the expected massive burst didn't happen. Sagittarius A showed only a slight flicker. But it won't always be this way. In the future, if a large mass of matter falls into Sagittarius A, the resulting energy could affect a large portion of our galaxy. This is called the quasar phase, and many galaxies in the universe have gone through it. What if the Milky Way goes through this? Since we're 26,000 light-years away, it's unlikely to destroy us directly. But such an event could increase the amount of radiation reaching Earth. Our atmosphere provides significant protection, but it's not easy to predict the long-term effects. Do you think such a future is possible? And will we still be here then?
Think about this, too. Our neighboring galaxy, Andromeda, is approaching us at a speed of about 110 kilometers per second. And in about 4.5 billion years, it will collide with the Milky Way. When this collision occurs, the black holes at the centers of both galaxies, Sagittarius A star and Andromeda's black hole, will draw closer to each other, and eventually they'll merge. This merger will generate gravitational waves, just like the signals detected by LIGO, but much more powerful. The mass of the new black hole formed when the galaxies merge could reach billions of solar masses. A new galaxy will be born. Perhaps it will contain new stars, perhaps new planets. And at the center of that galaxy, the descendants of Sagittarius A star will reside. 200 billion stars. They all orbit a single point. We too are part of this rotation, on a small planet
orbiting one of them. Whether we realize it or not, we are currently caught up in a galactic dance. And the choreography of this dance is written by an invisible monster 26,000 light years away. Sagittarius A star isn't trying to swallow us up. It doesn't even notice us. But we've noticed it. By observing the stars for decades, listening to radio signals, and combining data from 8 telescopes, we've seen the heart of our galaxy. Perhaps that's the greatest thing of all. Even though we're so small, we can understand something so vast. So, do you think Sagittarius A star will ever wake up again? And would we want to witness that moment? Let's discuss it in the comments.